In this illustration, we intend to simulate the pile draft in interaction with soil in the Abaqus software. The pile draft undergoes a uniform compressive load as much as 1 megapascal. The length and width of the soil is 40 meters and the soil is 25 meters high. The length of the piles is 16 meters and they are made of concrete. Here I select blind and enter the depth of cutting equal to 16 meters and OK in this manner. As you observe, the place where piles are set have been determined in this manner. Select plasticity and more column plasticity from the mechanical menu. Friction angle is equal to 30 degrees and dilation angle is equal to 20 degrees. Here I will click on Assign section, select the soil, done, and select soil from here and OK. In the next step, I'll click on Translate Instance, select the pile draft, select this point, then this one, and OK in this manner. And here you can observe that. In the next step, I will click on Create Step again. In the step 3, I intend to apply a compressive load to the pile draft. I'll select Static General from here, continue. Here I'll enter maximum number of increment as 10,000, initial increment size as 0.05, minimum as 1 multiplied by 10 to the power of negative 10, and enter the maximum as 0.1, and finally click on OK. Click on Create Boundary Condition. From here select Initial Step, select Symmetry, Anti-Symmetry and continue. Then I will select this plane and done. Actually this plane is a symmetry plane of the model, so I will select X Symmetric Boundary Condition for that. Click on Create Predefined Field, select Initial Step. From here select Geostatic Stress and here select the soil and done. The height on the surface of the soil is 25 meters and the stress is equal to 0. The height on the bottom of the soil is 0 and the stress is equal to rho GH. Rho is the density of soil, G is the gravity of the earth, and H is the height of soil. Well, I'll enter 1600 multiplied by 9.81 multiplied by 25. I will put a negative sign here and enter the lateral coefficient. In the next step, I'll click on Create Load, select Pressure Loading Strip from here, select Pressure from here and continue. I'll select the surface of pile draft and enter the pressure as much as 1 multiplied by 10 to the power of 6 Pascal in this manner. Here I will save the model. Here I click on seed edge, select these lines, done, and here I click on single. I'll put the minimum size equal to 0.3 and maximum size equal to 3 meters. Then I will click on select these lines again and done, and OK. I will click on mesh part instance, select the whole of the soil and done. In this manner the job of meshing is completed, which can be observed here. Here you can observe the deformation of soil. Here you can observe the quantity of the settlement of the soil. Here you can observe the plastic strain having been created in the soil. In the next step, I'll intend to calculate the quantity of soil settlement. I'll click on Create XY Data, from here ODB Field Output, and continue. From here I'll select Unique Nodal. Here I'll select U3 and select this node and click on Plot in this manner. As you observe, the quantity of soil settlement is equal to 15.7 centimeters. Here you can also observe the formation of the soil.